Hello everyone. We discuss here factors controlling nuclear fission reaction. In previous lecture, we already discussed that nuclear fission reaction. Now we discuss factors which controls that nuclear fission reaction. In nuclear reactor, fission reaction can controlled by two important factors. First factor is critical mass, and second factor is concentration of that fissible material. We discuss first critical mass and that concentration of material. That critical mass actually depends on concentration of fissible material present in that fuel and size of that material, that is surface area, concentration and surface area of that material, fuel. These two important factors affects on rate of nuclear fission reaction. First is surface area. Consider surface area of that fuel material. Surface area of fuel material. And second factor is concentration of that fissile material in that fuel. We discuss first critical mass. In fission reaction, neutrons are generated. In fission process, neutrons are generated throughout the whole volume of that fissionable material. Some of the generated neutrons escape at the surface and hence not available for further fission process. The number of neutrons that are lost, that are escaped from the surface, can be minimized by decreasing the surface area to volume ratio. That is, by decreasing the surface area of that fuel material, because that neutrons will escape from surface area of the material, and if neutrons escape, that are not available for further fission process. Therefore, that escape of fast moving neutrons can be minimized by decreasing the surface area of the material, fuel material. For a given fissionable material, there is minimum critical size, below which fission reaction not be sustained. That is, if surface area actually above which fission reaction will not be sustained, if we consider surface area, then if there is minimum critical size and if size is above that critical size level, then surface area will be more, which escape that neutrons, and therefore above that surface area, that fission reaction cannot be sustained. And second factor we discuss, that is concentration of that fuel material or fissionable material. The non-fission capture of fast neutrons by non-fissionable material like uranium-238 atoms, and their loss at the surface can be minimized by increasing the uranium-235 content in the reaction system, because uranium-238 is non-fissionable material and uranium-235 is fissionable material. Therefore, that nuclear reaction can be sustained by increasing the fissionable material concentration, that is uranium-235 content in the reaction system. And by slow down the fast neutrons, that fission reaction also controlled by slow down the fast neutrons by using moderator like heavy water, because if that neutrons are fast moving, then there is possibility of their loss is more, and that loss is minimized, escape is minimized by slow down that fast moving neutrons by using moderator like heavy water. The next point is multiplication factor, shown by letter K. Multiplication factor. For self-sustaining nuclear reaction, the rate of which neutrons lost and rate of which neutrons generated should be such that from each fission of uranium nucleus at least one neutron is available to bring about fission of further uranium nuclei. The rate of which neutrons lost and rate of which neutrons generated, this ratio should be such that from each fission of uranium nucleus at least one neutron is available for further nuclear reaction. This ratio is known as multiplication factor, shown by K. Therefore, multiplication factor K is defined as number of neutrons in one generation. Number of neutrons in one generation upon number of neutrons in preceding or previous generation. Number of neutrons in one generation divided by number of neutrons present in a previous generation, previous step in that chain reaction. Then if this multiplication factor K is equal to or greater than 1, that means equal to or greater than 1. If greater than 1, equal to 1 means in previous and in first and previous one generation and in previous generation neutrons are equal, then 1. If greater than 1, then in one generation neutrons number is more than previous generation, and in such situation, that nuclear reaction will be self-sustaining. That is, if multiplication factor K is equal to or greater than 1, then nuclear fission is self-sustaining reaction. And if that one is less than 1, if K is less than 1, then what is the situation? That is, in one generation, that number is less than previous. Then if such situation is there, then nuclear reaction will be not possible. That will ceases or slow down and finally not possible if K is less than 1. That is, for self-sustaining nuclear reaction, that K must be equal to 1 or greater than 1. And if less than 1, that nuclear reaction will not possible. When that K is 1, the number of neutrons produced at end of each generation will be exactly same in each generation. That neutrons number is same, therefore fission process continuous takes place at the same rate. If K is 1, fission reaction is continuous. Then we discuss here nuclear reactors. That nuclear reactor is a device in which fission reaction is carried out in a controlled manner so as to produce nuclear energy. That nuclear reactor is used, and in that nuclear reactor, fission reaction is carried out in a controlled manner. In atom bomb, that fission reaction is uncontrolled. That one is not possible to control. But in same reaction, in reactor, in device called reactor, nuclear reactor, that fission reaction is carried out in a controlled manner. This nuclear reactor is a device was first set up by Enrico Fermi in the University of Chicago, USA on 12 December 1942 at the time of Second World War, that is 1942. The basic components of the nuclear reactors are: first is fuel. It is target material on which the slow neutrons are bombarded. Actually, that are fast neutrons, but that are slowed down using moderator, and that slow neutrons bombarded on fuel material, which is known as target material. Then fissionable material like uranium-235, uranium-233, plutonium-239, that are used as nuclear fuels in nuclear reactor. Then next component, important component, is moderator. That fission of uranium-235 takes place by bombardment of slow neutrons, and the neutrons released in fission reaction are fast neutrons. The fast neutrons are more possibility to escape, and once they escape, that are not utilized for fission reaction. Therefore, that fast neutrons are slowed down when their kinetic energy is reduced, and the moderator is a substance which slow down the neutrons by reducing their kinetic energy. That heavy water, that is D2O, ordinary water H2O, or graphite material, that is liquid carbon, can be used as a moderator material in nuclear reaction. The next component is the coolant material. The fission process generated energy in the form of heat, and the coolant materials, that fission process generates energy. The fission reaction, nuclear reaction, generates energy in the form of heat. The coolant are used to remove that generated heat during the fission process, and for that purpose liquid sodium, inert gas like helium, or ordinary water can be used as a coolant. Then control rods. That fission reaction is chain reaction, and that chain reaction can be controlled by using cadmium or boron rods. That materials have high capacity to absorb the fast neutrons so as to control the fission reaction. Then reflector. The fast neutrons, if not slow down using the moderators, then they can be escaped and not useful for nuclear reaction. Therefore, the reaction vessel is coated inside with graphite, reflector material, that is graphite, beryllium, or lead silver alloy. These substances act as reflector, and they reflects the neutrons back into the core. That core is coated inside with that reflecting material so as to minimize the escape of fast moving neutrons. Then shielding. It is important for the safety of reactor. That this safety is of two types. First one is thermal shielding. The reactor core is a steel vessel surrounded by primary water cooling and high pressure cooling systems. This one is thermal shielding. That core where that fission reaction takes place is surrounded by primary cooling system. That one is placed inside water well or inside the cooling material, heavy water, etc. Then biological shielding. The 3 feet concrete layer it surrounds the reactor core. Actually, that reactor core is inside the land, and that one is coated with 3 feet concrete wall, which act as a biological shielding, and that can absorb neutrons and gamma rays if that are coming from that nuclear core. Then classification of reactors. These are the important 6 components of that nuclear reactor. That nuclear reactor is shown here in a figure. Here core is surrounded by that water, simple water. that inside the core heavy water which act as a moderator is filled, then that control rods are also there so as to control that fission reaction, and that one is filled with first fuel, that is uranium 233 material, or 235 can be used. Then circulation of that coolant, and here turbines at this side, that coolants, because of that he generated heat, that will be boiled and that will be converted in gaseous state. If liquid state water is passed from lower side, then from upper side that will be removed as a gaseous state high temperature water, that will again circulate here. Then from lower side cold water is passed, then from upper side very hot water, that is steam having very high pressure, is here. That water come out in a gaseous form with high pressure is passed to turbines, and that turbines generates electricity. This is that general layout of that nuclear reactors. Then classification of nuclear reactors. Nuclear reactors can be classified as on the basis of their use as a nuclear power reactor first. That one is used to generate electricity, and this one is nuclear power reactor general outline. Then research reactor used for research purpose, for in that one is for research purpose, for production of radioisotopes for study. That exist, nuclear reactors exist underground in large labs, large research labs. Then swimming pool type reactor, this one is also power reactor actually, and here it is heterogeneous type reactor used in several parts of the world, and this one is in enriched uranium in the form of uranium dioxide UO2. That uranium is here 233 or 235, which is fission material, is used as fuel, which is suspended in aluminum core, and that core containing fuel element is suspended in movable bridge. Here in this reactor core is fixed, that control rods and coolant material, that one is movable. But here in this case that coolant and control system is fixed and core is movable, that here control system is there, and from that control system that core is movable. That is, when core is outside the well, reaction will fast, and inside the well of control systems, suppose control rods, control material is there, boron, cadmium well is there, then if core deep inside, then neutrons will be absorbed and reaction slow down. And if any accident is there, this one is more advantages are more, because if any accident is there, then that if that system collapse, then that core will dip inside, and inside whole material is that neutrons capturing material, that will capture neutrons and reaction will slow down or stops, that fission reaction will be not sustained. Then that water pool with 20 feet depth is used, which act as moderator, reflector, shields and coolant in this reactor, in swimming pool type reactor. The advantage of this reactor is its facility to move the reactor core. Reactor core is movable and the pool is surrounded by concrete shield for radiation protection. Then here this is about that swimming pool reactor. Then we discuss that heavy water reactor, heavy water moderator reactor and breeder reactor in next lecture. Thank you.